Hey everyone, welcome back to Cars for Life. Ever wondered how a car makes a smooth turn without the wheels skidding or skipping? It seems simple, but there's a brilliant piece of engineering hidden in your car's axle that makes it all possible. Today, we're diving deep into the magic of the differential. At its core, a differential is a crucial component in every car, truck, and SUV. Its main job is to take power from the engine and allow the drive wheels to spin at different speeds. Now, you might be asking, why would they need to do that? Well, picture this. Your car is making a turn. The wheel on the outside of the turn has to travel a longer distance than the wheel on the inside. Think of runners on a curved track. The person in the outer lane has a lot more ground to cover. It's the same for your car's wheels. To cover more distance in the same amount of time, the outer wheel has to spin faster. If your wheels were connected by a simple solid axle, turning would be a nightmare. Both wheels would be forced to spin at the same speed. This would cause the inner wheel to spin too fast and the outer wheel to spin too slow, leading to them dragging, slipping, and fighting against each other. This not only wears out your tires like crazy, but also makes the car unstable and hard to control. This is exactly where the differential steps in to save the day. This ingenious device allows the left and right wheels to rotate at different speeds while still delivering power to both. So, how does it pull off this mechanical miracle? Let's break it down step by step, starting with the simplest design. The journey of power begins at the engine. It travels down the drive shaft and meets a small gear called the pinion gear. This pinion gear meshes with a much larger gear called the ring gear. As the pinion spins, it turns the ring gear. This is the first job of the differential, turning the power flow 90 degrees, from the front-to-back direction of the drive shaft to the side-to-side direction of the wheels. But that's not all. Notice the size difference between the pinion and the ring gear. The small pinion has to spin several times to make the large ring gear complete just one rotation. This gear reduction is the differential's second job. It slows down the rotational speed, which in turn multiplies the torque, giving your car the twisting force it needs to move. Now for the really clever part. Attached to the ring gear is a set of special gears called spider gears. These gears are the heart of the differential. The spider gears can rotate in two different ways. First, they are carried around by the ring gear as it spins. Second, they can also spin on their own individual axes, like little planets orbiting a sun. These spider gears mesh with two other gears called the side gears. Each side gear is directly connected to one of the wheels via an axle shaft. So the power flows from the engine, through the pinion to the ring gear, then through the spider gears to the side gears, and finally out to the wheels. Let's see how this all works in practice. When your car is driving in a straight line, both wheels need to spin at the same speed. In this case, the ring gear, the spider gears, and the side gears all lock together and rotate as one solid unit. The spider gears are carried around by the ring gear, but they don't spin on their own axes. They simply push on the side gears, making both wheels turn at the exact same rate. It's simple and effective. But what happens when you take a turn, say, to the right? This is where the magic kicks in. As the car turns, the inner right wheel slows down, and the outer left wheel needs to speed up. The spider gears make this possible. While they are still being carried around by the ring gear, they also begin to spin on their own axes. This spinning motion is what allows the speed difference. Think about the teeth of the spinning spider gear. On the side, meshed with the faster outer wheel, the spider gear's rotation adds speed. On the side, meshed with the slower inner wheel, its rotation subtracts speed. Let's visualize it. The spider gear's forward motion from the ring gear provides a base speed to both wheels. Then, its own spinning motion adds velocity to the outer wheel's side gear and subtracts the same amount of velocity from the inner wheel's side gear. The result? The left wheel speeds up and the right wheel slows down by the exact same amount, allowing for a perfectly smooth turn. It's a beautiful self-regulating system. When you turn left, the exact opposite happens. The spider gear simply spins in the opposite direction, slowing down the left wheel and speeding up the right one. This elegant dance of gears happens every single time you steer your car. For extra strength, especially in vehicles that carry heavy loads, you'll often find more than one spider gear. Standard cars usually have two, but trucks and heavy-duty vehicles might use a 4-spider gear arrangement inside the differential carrier to handle the greater forces involved. So, to recap, the differential performs 3 essential functions. It turns the power flow by 90 degrees, it provides a final gear reduction to multiply torque, and most importantly, it allows the wheels to rotate at different speeds during turns. The type of differential we've just explored is called an open, or standard differential. It's fantastic for normal driving on paved roads. However, it has one major weakness. Imagine one of your drive wheels is on solid asphalt, but the other is on a patch of ice or stuck in mud. With an open differential, the power will always follow the path of least resistance. The differential will sense that it's much easier to spin the wheel on the slippery surface. As a result, it will send almost all the engine's power to that one spinning, useless wheel, while the wheel with good grip gets almost no power at all. And your car, well, it goes nowhere. You're stuck. To solve this problem, engineers developed more advanced designs like the limited slip differential, or LSD. These clever devices can detect when one wheel is slipping and automatically redirect power to the wheel that has more traction, helping you get moving again. There are many different types of LSDs, from mechanical clutch-based units to viscous couplings and electronically controlled systems, but we'll save a deep dive into those for another video. So, there you have it. The humble differential is a masterpiece of mechanical engineering, working silently under your car to make your drive safer and smoother. It's a perfect example of how simple gears arranged in a clever way can solve a complex problem. Thank you so much for watching and learning with us today. If you found this explanation helpful, give us a thumbs up, and don't forget to subscribe and hit that notification bell so you won't miss our next engineering adventure. See you in the next video.